back, YouTube viewers. Today we got another problem we're going to work on. As I mentioned before, there's a few little issues to deal with, but today we're going to tackle this spooling motor problem that's going on a left spooling motor. And I think you're going to see in there what I finally do is reverse it. Take the board out of the left spooling motor, move it over to the right spooling motor, just because it's easier to do. But you'll see all that in here in this video. So really, let me not waste any more time. Let's get right to the video. Okay, so I'm now turning the right spooling motor, and let's watch to see those LEDs there. On, off, on, off. Okay, that's the right spooling motor. Now I'm going to turn the move roller. There you go. This one's a little harder to turn because it's very easy. And finally, we're going to turn the left spooling motor. That's it, I'm turning it right now. You see only the top one's coming on and going off. The bottom LED is not doing anything. Okay, now that we've seen the lights, the LEDs on the pinch roller gate board, let's look at actually what's doing all this stuff. Here's an entire shot of the spooling motor. So they're both really the same, but the spooling motor, complete assembly, and on the very top of this thing is where the reel of tape will sit. It'll sit actually on the brake drum, and it'll sit above this thing. And that very bottom thing there is the actual motor itself. Okay? But what we're concerned with is what's between the motor and that brake drum right there. So let's get a close-up shot of this. Here is a close-up. Now at the bottom of this picture, that's the disc. That's the actual optical disc that spins around with that. And if you look above, 1.11, that's the circuit board. That's the motor tacho circuit board that screws in with 4 screws into that housing there. And the optical sensor, okay, is on the back of that circuit board. And it goes in through that hole right there that you see on that housing and goes around that optical disc. So it actually can sense or sends light down through that disc and is blocked by the little black lines on that disc. And that's what does this. So as the motor spins, this thing will actually count those things or sense through them with the light up and down what's going on, and it knows the motor is turning. It actually will know the motor's turning, which direction it's turning, based on which way these pulses are going to be going. All right? So let's look at the actual schematic of this that will try to explain this and make it a little bit more usable. Now this isn't the actual schematic of this board. This is the new updated schematic, but I think it shows it better, so that's why I'm showing you. In the upper left-hand corner, that's the optical disc. That's what it looks like. There's the sensor, and you see the LEDs. It shows LEDs that are on the top. They shine through the optical disc to photoresistors on the bottom. On the right is the actual diagram of it, okay? But that's what goes on there with that optical thing. And the circuit drives, okay, down there is the thing. The circuit drives out 2 square waves, okay? And you notice that they are separated from each other, or excuse me, they're 90 degrees apart from each other. And so let's get a little closer look at that optical thing there. All right, now notice there's two rings, and notice the dark lines are actually about 90 degrees from each other. This is why you can't adjust that 90 degrees phase shift from each other. So one turns on, the other one turns on, and it's 90 degrees away from each other, hence the 90 degrees phase shift. And then if we go back here to the thing now, what you can adjust, both of these things have little trim pots in there, and you can adjust the duty cycle or the width of that square wave. And that's what we're going to wind up doing, okay? There's two trim pots in there, and that's what we'll do. But remember, this one's not working yet. So we really got to get it to work first before we can actually adjust that duty cycle in there of that. All right, here's the actual instructions. There's a layout of the board. This is the new board again. But you see on the bottom there, it says check the symmetry of waveform, the duty cycle, the square wave signals, 2 for each motor should be 50% plus or minus 10%. And at the very bottom, the phase shift of 90 degrees between the two square waves cannot be adjusted. Again, that can't be adjusted because that's done with that optical disc. Those black lines are set at 90 degrees from each other, and that's why it does that. All right, so let's take a look at the schematic of the actual one that I have. And this is really half of it. The optical encoder up there is the entire thing. Okay, you see the two the two LEDs feeding into two photo transistors, okay? And one of them, you see the lines are going down. The exact same circuit's going on below this, okay? So they actually have the exact same circuits. And it's just, but now there's a trim pot there. You see that little trim pot R11? I forget what the number is on the other side. But there's two trim pots to adjust that duty cycle, okay, of each one of these sections of it. And this one here has a dual IC and there's actually 6 points to the other IC, 6 sections of it to the second IC. Let's look at the actual circuit board. Here it is. This is the real circuit board itself. That 6 section ICs on the right next to the 10-way connector. The dual ones on the left next to the 2 trim pots, okay? Again, 1 trim pot for 1 square wave, the other trim pot for the other square wave. The optical sensor you can't see, you can see it's in the center, soldered in. Those are the 8 points. 2 of them are soldered together. That's why it's a bridge. If you look back at the schematic, it shows that. But this is the optical sensor. See the 4 holes right there? That's where those 4 screws hold it into that motor assembly. All right. Now, let's take a look at this board in the actual machine and understand the problems that I'm having with this. All right, so this is the left-hand spooling motor. And over here on the left, you can see the pinch gate roller board with those LEDs that I showed the close-up of how they worked. But way down under there, and see underneath that little ribbon, is that board, that motor tacho board. And here's the interesting thing. Look at the left-hand side of it. I'm going to point to it right here. There's the trim pots. It's absolutely impossible to put a screwdriver in there to adjust those trim pots on this board. There's just nothing. Everything's in the way. You can't get into that. So one more thing to look at before we go away and do the next part of it is, let's take a look inside the housing there. So there's the boards out. If you look closely in the housing, there's the actual the optical disc that the tacho runs on, okay? And you can see it's pretty much just like the diagram showed. Okay, now let me show you what I've done in order to troubleshoot and then align this board. Okay, so the motor tacho board, it's this right here, okay, basically has a 10-way ribbon it plugs in. And on the 10-way ribbon, 2 of the leads are ground, 1 and 2 is ground, 3 and 4 are plus 5 volts. It's just basically 5 volts goes in. There's a diode here to protect it like that, cap on the 5 volt supply. And there's 2 leads that come out. I believe it's 8 and 9 that go from this board up to the rest of the machine, let's say. Okay, so the outputs are 8 and 9. They're actual outputs. And the input into this board is just ground and 5 volts. One thing that I did notice is when this is unplugged from the motor, okay, if this was still up installed in there, the motor then will spin every time you press fast forward or rewind. This is we moved it over to the fast forward one now. So if I press the button down, the motor will freely spin. If I plug in the connector, it won't spin, okay, because this board's not working correctly. But so what I did, okay, and so in order to troubleshoot it, really all we need is 5 volts and ground here, okay, and then we could take a look at what's going on. And how I'll do this is I'll actually then just take a piece of tape and insert it here. Okay, and there's going to be 2 things, and so I can then see how this will react to that. All right. Now, because I can't get into the 2 trim pots when that board is installed correctly, because they're over on this side here, I've come up with this. I've made this adapter here. Okay, so I have a 10-way header to a 10-way connector. And what I've done is I have power and ground on this wire here. And I took the 2 signal lines, okay, that come out of this board and disconnected them so they don't feed into the rest of the machine. So with these 2 signal lines disconnected, this motor will be able to spin freely. And once I get this board to work, I can then screw this board in backwards, okay, because it doesn't matter. We just got to go through that disc, and the 2 trim pots will then be accessible from the far side now, which will be make it a lot easier to adjust that 50% duty cycle that they're talking about. All right, so in the meantime, with the power running down here, what I'm going to do is I'm going to look at those 2 signal lines while putting that piece of tape through there. Okay, so just really quickly, here's the board again. I've now taken those 2 signal lines. I have my 2 probes on the signal line outputs of this board, okay? So it doesn't go anywhere else but to there. And I put a ground over here to the cap, like that. And so we're going to turn the machine on, and we're going to run, we're going to put this piece of tape through here. I'll give you a picture of the scope, what happens when we do that. Okay, so there's my 2 signals. This is ground. It's sitting at ground right now. I'm going to turn the machine on right now. Give it a second to stabilize. Okay, and what should happen is when I pass that piece of tape through there, this should go up. This is 5 volts per division, so it should go up 1 division here, 1 division there for each section of it. All right, and I'm ready, and here we go. Up, up. So that, okay, it's working now. And the reason it's working now is because I've replaced this thing right here, the optical sensor. The optical sensor was bad. This is what's been causing me grief for a long time now. So now I have this thing actually working. Both photo cells are working. They're sensing that. I'm going to install the board into there, like I said, backwards, so I can run that motor and set these duty cycles with the little trim pots, just to make sure. However, I went back. These are the original ICs in here. The only thing is really different is that optical sensor is the new optical sensor in there. All right, now let's put it into wind mode. And there's our 2 square waves. That's what you kind of expected to be. So let me get trim pot, see if we can adjust this thing here. All right, hold on. All right, here we go. Let me put this on. Screw. We're on the trim pot here. Hard to see what I'm doing. Here we go. I'm on the trim pot. We'll go on the wind. Looks pretty good right now. See, this is about 1 section wide, top one right around that, coming in right in the middle of it. I think that's 50% plus or minus 10%, as they say. All right, so as you can see, the spooling motor problem is corrected. Both spooling motors are working. The motor tachos are working. I'm getting a signal to the pinch roller board. I got to go farther from this now because there's still some issues where this is not working correctly and it's not tensioning the tape. But at least we got these 2 boards running correctly now and sending the correct signals onwards. So until next week, like I always say, if you hasn't subscribed to the channel, please subscribe to the channel. Give it a thumbs up if you enjoyed the video, and click the bell for notifications, and I'll let you know when the next one's coming out. Thank you very much for watching.